first question is, what the difference between a null hypothesis and alternative hypothesis? Firstly, a null hypothesis is a statement in which there is no relationship between two variables. However, alternative hypothesis is a statement in which there is some statistical significance between two measurable phenomena. Null hypothesis, the mathematical formulation is equal signs, but alternative hypothesis is unequal signs.
For question 1b, what is the difference between a one-tailed test and two-tailed test? First, direction. For two-tailed test for an effect is only one direction, while in two-tailed test for an effect in both directions. Second, critical region. All the significant level is placed in one tail of the distribution, either upper tail or lower tail for one-tailed test. And for two-tailed test, the significant level is split between two-tailed tests of distribution with A divided by 2 in each tail. For alternative hypothesis, for one-tailed test, specify that the parameter is interest is either greater than or less than a certain value but not both, while in two-tailed test, specify that the parameter of interest is different for a certain value. It could be greater or less. So for question C, what is mean by a p-value? P-value is statistical measurement used to validate a hypothesis against the observed data. Measure the probability of obtaining the observed result, assuming that the null hypothesis is true.
Hi, my name is Nur Aizalika bint Abdul Aziz. My number matric is 299771. So, for this question, we must determine that HO is population mean equal to 6.6 and H1 is population mean equal to 6.6. Significance level is 0.05. The sample size is 7, so the degree of freedom is 7 minus 1, which is 6. So for this question, we will use the t-distribution table to find the critical t-value. So t-critical is 2.447 and we will use the calculator. For sample mean, we got 7.56 and standard deviation, we got 1.18. Next, the formula for test statistics is sample mean minus population mean divided by sample standard deviation and divided by the square root of sample size. 7.56 minus 6.6 divided by 1.18 and divided by the square root of 7, and we got 2.15. For the decision, 2.15 is outside the computer area, so HO is not rejected. So, we can conclude that the mean weights at birth are different from 6.6 pounds.
For question 2a, list the 5 steps to perform the hypothesis testing. Step 1, formulate the hypothesis, HO and H1. Step 2, choose the significant level based on the question. Step 3, select the test and calculate the test statistic. Step 4, formulate the decision rule. And step 5, make a decision and interpret the result, whether reject or not reject HO.
For this question, step 1, we must determine the HO is population mean less than equal to 90 and H1 is population mean more than 90. Step 2, set the significance level at 0.10. Determine the sample size, which is 100, giving us 99 degrees of freedom. Step 3, use the t-distribution for the analysis. Step 4, our critical t-value is 1.29t and we reject the null hypothesis if our calculated t-value exceeds this, which is 1.290. The calculated t-value from our data was 1.818. Since 1.818 exceeds our critical t-value of 1.290, we reject the HO. Based on our analysis, we can conclude that there has been a statistically significant increase in the selling time for farm properties in Nebraska.
The first step is state the hypothesis. So the question is a greater than. So the HO is mu F less than mu R, and H1 is mu F more mu R. So the step 2 is the significant level is 0.10 based on the equation, and the step 3 is select the test hypothesis. We will use the distribution because standard deviation is unknown. Step 4 is rejected. HO if calculated T more 1.363. So for the step 5, find the mean and standard deviation for fast food and restaurant and calculate the T value. So we have a mean of fast food is 142.5 and standard deviation for fast food is 12.243, and mean for restaurant is 140.29 and standard deviation for restaurant is 50.79. The next step is put the standard deviation, which is 6 minus 1 times 12.24 square plus 7 minus 1 times 15.79 square divided to 6 plus 7 minus 2. The answer is 204.09. To get the t value, we need to S bar 1 minus S bar 2 divided to square root of sample standard deviation times to 1 per n1 plus 1 per n2. To get the t value, we need to 142.5 minus 120.29 divided to square root of 204.09 times 1 per c plus 1 per 7. The answer is 1.54. So 1.54 is the inside the rejection area. So we need to reject HO. So we conclude that the mean salary are greater for the fast food workers than the restaurant workers. So the p-value is between 0.05 and 0.10, which is 0.0751 by 0.05 plus 0.10 divided to 2. So we get the answer is 0.075.
Since the keywords is effective, we state that HO is mu less than or equal to 0 and H1 is mu more than 0. The significance level for step 2 is 0.05. Sample size is 7, so the degree of freedom is 6. Step 3, we will state that we will use the t-test. The fourth step is our critical t-value is 2.447 and we will reject the HO if our calculated t-value exceeds this. Step 5 is to find the mean of the differences, which is 2, and the standard deviation of the differences, which is 2.082. Same step to compute the value of t and make a decision. T is equal to the mean of the differences divided by the standard deviation of the differences and divided by the square root of sample size. So we calculate using the calculator and we got the value of t is 2.542. So the decision is 2.542 is inside the rejected area. So we reject HO. We can conclude that the training was indeed effective in improving the customer's relationships.
Treatment degrees of freedom increased by 1. So degrees freedom treatment plus 1. So the answer is 3. Question 2. What the total sample size? N equal to degrees of freedom total plus 1. So we get the answer is 12. Question 3 is what is critical value? We need to find the DFE. So DFE total minus 2 DFE treatment. 11 minus 2, we get 9. So 9 is a DFE. Given the 0.05 is significant levels, DFE total is 2. 2 is a numerator and DFE errors is 9. 9 is a denominator. Using this table, we get answer 4.26. Question 4. Write the null and alternative hypothesis. So HO is mean 1 equal to mean 2 equal to mean 3. And H1 is at least one treatment mean as a different. Question 5. What is your conclusion regarding the null hypothesis? So first, we need to find the SS error and SS treatment. SS error equal to MS error times DF error. So 20 times 9, we get the 118, and SS treatment equal to SS total minus 2 SS error. So 500 minus 118, we get the 320. So the next step is to calculate the element equal to SS total divided to DF total. So 320 divided to 2, we get the 116. So to calculate the F value, F equal to MS total divided to MS error. So 116 minus 2, we get the X. F value is 8. So the calculation is F value 8 is greater than critical value is 4.26. So we need to reject HO. So we calculate that not all mean of treatment are equal, at least when they are different.
For question 3C, step 1, HO equal to mean G equal to mean I equal to mean C. H1, the mean are all not equal. Reject HO if compute F greater than F critical. Step 2, the 0.05 significant level is set in the problem. Step 3, by using the F statistic. Step 4, reject HO if computed F greater than 3.295, parameter of critical F, degree of freedom numerator 3 minus 1 equal to 2, and degree of freedom for the denominator is 35 minus 3 equal to 32. For step 5, using ANOVA table, we can conclude that F compute 3.295 greater than 3.03 critical HO is not rejected. We can conclude that there is no different flight time between the three airlines.